In this video, we're going to be recording an individual integral. It's going to be a basic U-substitution integral that would probably be found in a common Calc 1 class. We've got the integral of 1 over cosine squared 2x dx. First off, I'm going to want to take this and do a trig substitution. So we're going to say that this is equal to the integral of secant squared 2x dx. All right, that's going to let us easily then let our u be the inside portion of this function. So we're going to let u equal 2x. From there, I'm going to take the derivative of both sides. Du is equal to 2 dx. I'm going to go ahead and solve all the way down for dx. So I'll have a du over 2 is equal to my dx. Okay, from there then we're going to come back up and we're going to see what we can substitute out. So we'll have the integral, we'll have secant squared. For that 2x, I'm going to replace that with a u. For the dx, I'm going to replace that with what we said that was equal to, so du over 2. From here I'm going to be able to take out the 1/2. So we'll take out that 1/2 and then we'll have the integral of secant squared u du. Now we've got it down to an integral that we can integrate. Hopefully you have the integral of secant squared u memorized as tangent. So then I'll have a 1/2 tangent u plus c, and then I can replace my u in here as 2x. So a final answer of a 1/2 tangent 2x plus c. So definitely a straightforward U-substitution integral, one that you would find in a Calc 1 class. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks. In this video, I'm going to be working out an individual integral. It's going to be a straightforward U-substitution with absolutely nothing fancy about it. So I've got the integral of sine x over the square root of 1 minus cosine x dx. So for a U-substitution, I'm going to look for the inside part of any composite function that I might see there. So in that denominator, I've got the 1 minus cosine x on the inside of the radical. So that's where I'm going to start with letting u equal that. So u is going to be equal to 1 minus cosine x. Then I need to take the derivative. Alright, the one's going to fall out. I'm going to have the minus sign that's already there, and then the derivative of cosine is a negative sine x dx. A negative times a negative is going to make that a positive, and I am going to want to solve for dx, so I'll just divide both sides by that positive sine x. So I'll have du over sine x is equal to dx. Okay, then I'm going to come back up to my original integral, and I'm going to start doing some substitutions. I'll have that sine x will still be in my numerator. In that bottom, I'll have the square root of a u, because I'm going to replace u with what I said it was going to be equal. When I replace dx, I will have a du over sine x. That's going to allow those sine x's to cross out, which is going to leave me with the integral of 1 over square root of u du. I'm now in terms of all u, so then I can start to integrate this. I can rewrite this as u to the 1/2 and move it up to the top, which will make it negative. So I'm going to rewrite it as the integral of u to the negative 1/2 du. Now it is to a place where I can integrate this. Integrating by adding 1 there would give me a 1/2. So in front, 1 over 1/2 will give me a 2u to the 1/2 plus c. Rewriting this in radical form, since I had a radical up there, is going to give me 2 square root of u plus c. Replacing u with what it is will give me a final answer of 2 square root of 1 minus cosine x plus c. So a pretty straightforward integral using that U-substitution method. Definitely thanks for watching. If the videos are helping, don't forget to subscribe to the channel and share with your friends. Thanks. Okay, in this video I'm going to do an individual integral. It's going to be a basic, straightforward U-substitution, one that would probably be found in a Calc 1 class. Now, to make this problem shorter, I am going to assume that we know, or that you have memorized, the integral of tangent x dx being the natural log absolute value secant x plus c. Alright, other equivalent answers you might have memorized that it's equal to a negative natural log absolute value cosine x plus c. All right, equivalent answers. I'm just in this particular one using this one. All right, if that's memorized, this integral is a whole lot shorter. Okay, so we're going to start here. Letting u be our inside function. All right, in that numerator, we've got the tangent of the natural log of x. So I have a composite function there just in the numerator. All right, this is the inside function, tangent is the outside function. So I'm going to let my u be natural log of x. Okay, then I'm going to take the derivative of both sides. Du is equal to a 1 over x dx. All right, I want to solve all the way down for that dx, so I'm going to multiply both sides by x. So I'm going to have an x du is equal to a dx. Okay, now at this point I'm going to come back up here and I'm going to do some substitutions. All right, so I'll still have my tangent. All right, I let u be the natural log of x there, so I'm going to have a tangent u all over the x, which is going to stay. Dx then is going to be replaced with what I said it was going to be equal to, which is an x du. All right, now that's going to let those two x's cross out. All right, and I'm going to be then down to the integral of a tangent u du. All right, now at this point, if you do not have this memorized, then this becomes a much, much longer problem. But as long as this is one of your standard integrals that you have memorized, this then becomes actually very quick here because I can integrate right away. I know it's going to be the natural log, absolute value of secant u plus c, and I can replace my u with the natural log of x. So then I'm going to have natural log absolute value secant of that natural log of x, absolute value plus c. All right, and definitely if you don't have that memorized and you need to see all of the steps that would be encompassed right there from not having this memorized, I do have other videos where I actually do the integral of x. All right, but assuming that you've got that memorized, this actually becomes a very straightforward, pretty short integral. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And then don't forget to subscribe to the channel and give me a thumbs up whenever you can. Thanks. In this video, I'm going to work out an individual integral. We're going to take a look at the integral of e to the x plus cosine x all over e to the x plus sine x dx. This one is a relatively straightforward. We're just going to use a u substitution. Taking a look at that denominator there, we can see that when we take the derivative of sine, we get cosine, and when we take the derivative of the e to the x, we're going to get the e to the x, which is going to make that numerator cross out there. So we're going to let u equal e to the x plus sine x. All right, and then we'll take the derivative of both sides. Du equals e to the x plus cosine x dx. We'll go ahead and solve for that dx, and dividing both sides by that, we'll have a du over an e to the x plus cosine x equaling our dx. All right, and then we'll come back up and we'll do our substitutions here. Okay, so the numerator will stay e to the x plus cosine x. We will replace that denominator with u, and we'll replace dx with what that equals, du over the e to the x plus cosine x. All right, from there then we are going to be able to see that real nicely those e to the x plus cosine x's cross out. That's going to leave us with the integral of 1 over u du, and that one we have memorized as being the natural log absolute value of u when we integrate that. So putting that u back in, we'll have natural log absolute value e to the x plus sine x, and then plus c for a final answer there. So pretty straightforward on a basic u substitution there on this one. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit as well, and don't forget to subscribe to the channel. Thanks. In this video, I'm going to be working out an individual integral. We're going to take a look at the integral of cosine 3x all over 5 plus 2 sine 3x dx. It is going to be just a straight u substitution integral. So for that reason, if I kind of take a look at this and I know that the derivative of sine is cosine, then I'm going to want to go ahead and let my u be that entire denominator right there. So I'm going to start by letting u equal 5 plus 2 sine 3x. Alright, then I'm going to take the derivative of both sides. I'll have a du is equal to, this is going to go away. Taking the derivative here, can't forget chain rule, you're going to have an extra 3 that's going to be multiplied by that 2 out in front. So we'll have a 6 cosine 3x dx. And then I'm going to go ahead and solve for dx. So I'll have a du over a 6 cosine 3x equaling my dx. After we get done there, we will come back up here to our original problem and we'll do some substituting. So I'll have the integral of cosine of 3x in my numerator, replacing that denominator with u, and then replacing the dx with du over a 6 cosine 3x. Now, those cosine 3x's are going to cross out real nicely. I've got that imaginary 1 that's in front there, so I can pull out that entire 1/6 right there. So we'll pull out that 1/6. Then I'll have the integral of a 1 over u du. Alright, hopefully at this point you have this memorized as being the natural log absolute value of u. So we can integrate that pretty simply with a 1/6 natural log absolute value of u plus c, and then replacing u with what we said it was going to be, we'll have a 1/6 natural log absolute value 5 plus 2 sine 3x, and then plus c. Definitely a straightforward u substitution there. And if you're at the beginning of Calc 1 and you're doing a lot of these u substitutions and you get the hang of how you have to pick u, then they all turn out to be relatively simple. Definitely thanks for watching. If the videos are helping, please share with your friends so that they can benefit too, and don't forget to subscribe to the channel. Thanks.